Hi, so today in this video we're going to be covering chapter 3.3.2, which is the composition of a function and its inverse function. I only have 3 examples. Since most of it is pretty much the same, I just wanted to cover this quickly. So we have which of the following is not an acceptable way to show that f of x equals x plus 5 and g of x equals x minus 5 over 8 are inverses of each other. We cannot, show that f of x and g of x pass a horizontal line test. That is not acceptable because they could both pass the horizontal line test, but they could be completely different functions. Like, for instance, you could have this, and the inverse of this would be this, and they both pass the horizontal line test, but you could also have something like this. This, and the inverse could be something, I don't know it off the top of my head, but like this sort of, or like, like this. And these would both pass a horizontal line test, but they would be different graphs. So that is the answer. That's not an acceptable way to show. We know that the table values of f of x and g of x are going to be inverses. So like if you have f of x and one is like xy, then 1, 2, 3 should be like 2, 4, 5. And then the inverse of that should be x, y, 2, 4, 5, 1, 2, 3. Like this. And you could see that these are inverses because their coordinates are just swapped. So that is an acceptable way. And then comparing the graphs is an acceptable way. And the function composition will be the same if you do it. We'll get into that in just a minute. If f of x equals x plus 8 and g of x equals x minus 8, it wants us to find the function compositions of both. So first we'll do f of g, and if you see f of g of x like this, it's exactly the same as writing f of g, like our fog and then of x. It just basically means that the g of x is being turned into the x. So we have x minus 8 plus 8 because we're doing f of g. And then this will turn into x, so we'll have x. And then for the second, we'll have x plus 8 minus 8 for the g of x, g of f of x. And this will turn into x also. So these both will turn into x, and the answer will be inverse because they both need to turn into x for them to be inverse, the function compositions, if you do the function compositions for both. Here's just one more example. We can find that they're inverses by either finding the inverse of one of them, or we could do function composition. I prefer doing the inverse, so I have y equals 18, x plus 28, x equals 18y plus 28, x minus 28 equals 18y, x over 18 minus 28 over 18. This 28 is not over 18, so no, they are not inverses. That's just basically lots of examples like that. And a lot of them are like this, and a lot of them are like this, and there are lots of different ways to figure out if they are inverses of each other or not. It's just whichever method you prefer better. Yeah, if you have any questions, please let me know. I know I kind of didn't cover this one as in depth, but yeah, just reach out. Yeah, have a good one.